Okay, good morning, everyone. Good morning to the persons who attend online, and welcome to this last day of the FEHRL conference. So we will start immediately so that we are not delaying all the rest of the day. So my name is Xavier Cocu. I'm research coordinator at the Belgian Road Research Center, and I'm pleased to moderate this session as the chairman of the research committee at FEHRL. Very pleased because it's about a research project, about innovation, so definitely it's part of the research committee tasks at FEHRL. If you look at the strategy, the first strategy, you will find 4 pillars, and 3 of these pillars are definitely linked with such a session, I would say. So boosting cooperative research, development, and innovation. Typically, it's what these projects are doing, definitely. Enhancing knowledge development and transfer. That's typically what we'll do this morning. And fostering innovation. I think that we will learn a lot about, indeed, innovation across different sectors, innovation in the road transport, but based on very interesting technologies. So The session will highlight several research in which FEHRL members also are involved, together with technological partners from different horizons, so it will be very interesting. We also heard several information about two important FEHRL initiatives. And we will start with BDPAVE in particular, and we will end with the initiative Low Noise Pavement. And in between, we will have projects addressing the critical issues of resilience, risks, and robotics in transport infrastructure. So you see a quite good variety of topics, but I feel it will be very interesting. So I will not say much more. I will immediately invite our first speaker. So Dirk Janssen is head of section at BAST, the German organization, and will present us what the status of the BDPAVE initiative. So please, Dirk. Yeah, that's it.
Thank you very much for this kind introduction, and good morning to everybody. We will start smooth with a short movie about BDPAVE.
What does it take to make a journey smooth and enjoyable? Most of all, it's the road itself. A good road surface is often taken for granted, but every smooth road is the result of a deep understanding for road construction, management, and interpretation of data. The FEHRL initiative, BDPAVE, brings together the expertise of 32 road research institutes and their newest scientific findings across Europe and beyond. Working closely with infrastructure owners, FEHRL has access to unique domain knowledge, like construction plan, road condition, and traffic load data. Data that builds the foundation for smart pavement deterioration models that make roads more resilient. In BDPAVE, we collect traditional and new data sources with cutting-edge technologies to turn big data into smart data, relevant and actionable. Our models will help better predict deterioration of road surfaces so that maintenance measures can be planned and undertaken ahead of time, with a minimum of investment, keeping the impact of roadworks on traffic flow low. A smooth journey is something everyone hopes for. Let's create it together. To discuss how you can get involved, get in touch at bdpave.eu.
So you see, it's all about pavement management, and as you know, pavement management is to find the best solution for your network, depending on the status of the roads, of the pavements, as well as the available budget. And these processes amongst pavement management are mostly standardized and well known. And the heart of the pavement management systems are these kind of behavioral curves. With them you can make the prognosis how the different aspects of your network will change. These behavioral curves are mostly based on empirical evaluations and empirical values. So, and they have room for improvement. And they are as simplified, or they are as simply as this very simplified example here. Nowadays, the large and partly unused amounts of data we can use to precise or to update these behavioral curves. So, as said, we have vast amounts of data available. The data is available at an enormous speed, mostly also more or less in real time. The data is there virtually for all parts of the network, and at most data sources it doesn't make any more difference if it has been collected for project level or for network level application. But the hurdles to use these data are still enormous. So there are challenges in the data quality, data accessibility, the interfaces, even in the definitions, and of course in the data processing in general. The mission of BDPAVE is to overcome these hurdles and challenges, and to bring knowledge and experts together to discuss about that and to find solutions. So BDPAVE is more or less a knowledge management point, a knowledge management system, and a platform for achieving a common goal. The goal is to screen the whole processing chain of turning big data into information or into smart data to achieve improvements in asset management. And therefore, we look out what kind of information, what kind of projects are out there, what kind of finalized projects, running projects or planned projects. And we try to bring this knowledge together for our common goal. These projects have a wide variety of topics. So it's about object type libraries, about BIM, about the use of smartphone data or floating car data, and so on and so forth. BDPAVE itself, it's organized in work packages. This helps us to work in this initiative. So we want to look what is the best practice done nowadays to find out what is missing or what can be improved. Even on the data sets, we ask ourselves what is missing, what is needed, and how to access the data. This is a very crucial point. Then we bring this all together at this here called work package number 5, usage of data. This is the heart of BDPAVE, where we actually work with the data, for example, with AI technologies and so on and so forth, and where we want to find the right solutions in the end, to achieve the goal of the initiative. Artificial intelligence is an essential tool for transforming big data into information. However, an AI is not intelligent on its own. It must be trained and it must be processed accordingly. And even then, AI is and remains only a concept, a procedure, nothing more. It's not really intelligent. Cannot, or from my opinion, never be really compared with human or natural intelligence. This is something we have to call ourselves every time. But what makes AI so powerful is the ability to scan through mass of data, an ability we cannot do with our natural intelligence on this level. A striking example is the never-ending stream of data uploaded to social media platforms like YouTube or Instagram. These data flow is never ending, and it is massively, and you cannot, with the natural intelligence or with man-made solution, you cannot look if these data streams violates the usage guidelines of these platforms, but an AI can do. So AI therefore plays a significant role in BDPAVE and in general. So it is primarily about translating human expert knowledge into algorithm and processes. Therefore, we have on the one side the domain knowledge. For example, in our case, it is the pavement engineer who has a man-made solution. Then we have the data scientist who translates between the domain knowledge, between the pavement expert and the computer while coding. And the computer only tries by doing try and error to find a solution by going through the jungle of data he has. And this general principle is always, more or less, always the same. And these 3 steps shown here are also more or less always the same, independent which kind of technology, big data, and AI technology you use. First, you have to prepare the data, a very important step and a very time-consuming step, because only with prepared data you can really dig through the data. You can do the data mining, or the computer can do the data mining, which means finding the right solutions, finding patterns in the data which fit from the input data to the solution. And with this, you generate solutions, and when you put all solutions together, you come to the knowledge you want to have. But besides all the advantages, we have to be aware of misinterpretations of the AI, because AI can only be as good as the input is. And this is a very crucial factor. A healthy mistrust is therefore obligatory. To underline this, I will show you the following example. This is a fish, a tench. Latin name is Tinker Tinker. And there is an AI that can identify different fish species. And the Tinker Tinker at this AI technology, it showed a very high hit rate. So everywhere, every time you showed a Tinker Tinker or a tench to the AI, it immediately identifies it as this kind of fish. So the data analysts asked themselves, why has the Tinker Tinker such a high hit rate? Is it because of the special shape of the fish or the fins or whatever? So they dig into what the AI or what the computer has done. And they found something very surprisingly. This fish is a popular trophy for fish hunters. And you can do it by yourself. Just Google tench or Tinker Tinker, and you find a lot of these kind of pictures. A fish hunter holding his trophy, holding his fish. And it turns out that it was not the shape of the fish, and it was not the fish hunter who identifies the Tinker Tinker. It has been the fingers. So every time the AI saw a fish with fingers, it says it's a tench. So simple. So what has this to do with pavement engineering? Something, I will tell you. For example, think of surface images. We want to use AI to dig through our surface images. And imagine how hard it is to tell a computer what is a crack, what is an alligator crack, what is a sealed crack, what is a joint, and what is just a line of, made of dirt on the surface. This is the same problem. It all depends on the input and the output you gave for training. So the good thing about that is that these problems are always the same. It doesn't make any big difference if you're talking about fish, pavements, medicine, or whatever. The problem is always the same, and so are the technologies. So we can easily adopt these technologies to our problems when it, for example, comes to pavement management. And BDPave tries to provide the framework for this. So we started with to conduct a survey throughout Europe and asked the pavement management people out there, what kind of data do you have, what kind of data do you need, and what kind of data are you missing? And it turns out the data situation is quite good amongst Europe for the pavement management, but there are still some data sources which are hard to get, for example, like bearing capacity data, and data which are wanted in future or wanted now. These are, for example, data about the environmental impact and sustainability and so on and so forth. But we are on the right way. But you see, to get the right data is still an issue. Therefore, I will show you 3 projects which are in context with BDPave and which are from institutes, or institutes participate, which are in BDPave, which deal about data. The first one is this project from the Swedish Transport Administration and Infra Sweden. It is about connected road surface measurements. So the Swedish colleagues have the problem. They have a regular pavement inspection with dedicated measurement vehicles, but they wanted to they want to close the gap between the measurements. And therefore, they said, maybe we can use probe car data, floating car data, it's also called this way, to complement the traditional measurements, not to replace. And they made a screen through the market, and they found out the market solutions are there, but they do not really fulfill all the needs they wanted. So they initiated this project, and they invited 3 data providers, Nara Dynamics, Mercedes, and Universe, to collect data throughout the network and to find better and new solutions for their tasks. Second project is Augmented CCamp. We talked about this yesterday. It's a Horizon Europe project, and it's coordinated by FEHRL, and one of the partners is the Latvian State Roads. So in Latvia, there will be a test site where they collect a lot of data to create HD maps and digital models for use in various applications. And they will use LiDAR technology and photography technology to gather all this information. And then the maps will be updated from roadside units. Also, this is a very worthwhile part for BDPAVE, and I'm happy to connect with Augmented CCAM. Last one is more or less the twin of BDPAVE on the US side. In the US, there is a new pooled fund study called Emerging Data Streams for Pavement Asset Health Monitoring and Management. And the colleagues there want to do more or less the same we want to do at BDPAVE. They want to identify, test, and evaluate the emerging big data streams that may enhance the process we use to evaluate the performance and management of our pavement assets. And they will start also with this vehicle response data collected by connected and automated vehicles. And afterwards, they will also include smart infrastructure, sensors, mobile devices, and BIM technologies. And it's more or less, as said before, the same we do here in Europe with BDPAVE. And again, I'm also very happy that we have this opportunity and that we can connect with them. That's all from my side. Thank you very much for your attention. So get in touch, like said on the video, and for this, have a look on bdpave.eu or give me a call. Thank you very much.
Okay, thank you, Dirk. Of course, we can have some questions. So if someone has a question to Dirk in the room or in the chat, so for the one who attend online, do not hesitate to ask questions directly in the chat. We will, of course, try to answer. Yeah, Karen.
Yeah, thanks, Dirk. That was really interesting. I'm interested in the link with BIM. So it was mentioned there in a couple of the slides, and a lot of the focus at the moment in the area of BIM is about information management and kind of structures and a more formalized approach to collecting and gathering information. Is that a role you see within BDPAVE?
Yeah, it's about the structure and the formalism you said. As far as I understood, BIM is not the level of information or the level of detail is not good enough for pavement management, as I understand it, like seeing a crack or something else. It's more about there is the road, and you can describe the road with in a formalism or level of detail which is not digging so deep as we need it. But you're right, it's about the structure. It's about how to deal with the data, and this is something we have to learn or have to adapt in general.
Any other reaction? No? Okay, so I understand that it's a knowledge sharing initiative. It means probably that you are still open to get information from other projects, to be in contact with other projects. So, yeah, okay. So we'll move to the next, as far as I succeed in launching it. It's already open, you say it. No, that you do. Okay. So it's not really a project, in fact. It's much more than this, or I would say. So it's RIMA, for robotics for inspection and maintenance of infrastructure. And so I will welcome Chris. Okay, I cannot change from one to the other. Welcome Christophe Leroux. So we are from the, in French, Commissariat à l'énergie atomique. So I would say it's about nuclear atomic applications, but your expertise, your career is in robotics, definitely. So I will just quickly give you the floor. Thank you.
Yeah, thank you very much for welcoming me in this audience. Yeah, the CEA is the French Nuclear Commission, but I'm part of the technology branch, which is, and especially I made my career in applications of AI in robotics. So we'll be talking about this project RIMA. There is a lot of slides, but I may switch over some of them rapidly because, and you can have them as a backup if you are interested in all the material that we'll be talking about. RIMA is a project that started in January 2019, within which FEHRL is a partner. And it's a project which has one main objective was to create a network of digital innovation hub, that is a network of organization that would favor the innovation in robotics for inspection and maintenance of infrastructures. This project has two groups of partners. One which are the digital innovation hubs, and you can see the locations on the map there. So we're spread over all Europe, and we are also aiming to grow. To demonstrate the effectiveness of this network of digital innovation hub, we received more than 8 million euros that we redistributed through open calls to SMEs to create new products, new services, and develop their activities. So the two groups of partners, we have these groups of these groups of digital innovation hubs, which are mainly research organizations. So we have in our partnership, as I said, in the group of facilitators of sectorial associations, and which are helping us to make the connection with the industry and the different sectors that we are covering, but also the research organizations like DTI, which I think is in the room right now. So the approach and what is about this, what are these digital innovation hubs? It's something that gained interest since 2016 in the which is an initiative coming from the Commission to favor this innovation in robotics. So what we can say now is that our network is operational. The project will finish in June 2023 this year. It's part now of the Digital Europe Industry Initiative. It's the follow-up of these actions will be part of that. And we have been, through this project, organizing a community tool, what we call a community tool, that is a web portal, basically, where you can find a lot of information about the application, the possible applications of robotics for inspection and maintenance of infrastructures of different domains. A small market study that we also undertook about the possibilities of usage of robotics in these different sectors that we're covering. So the domains that we cover are rather broad, since it covers energy production and distribution, including renewable, oil and gas, nuclear, for the production of energy, photovoltaic, wind turbine. We are also interested in covering transport, so air, routes, waterways, and maritime. So we are also covering this water supply and sanitation sector, and communication infrastructure. So you see it's a very vast set of sectors, and one of the interests that we realized is when gathering all these sectors that most of the time and frequently there is a commonality between the problems that you could have, that people could have in for instance in water supply and sanitation, and in nuclear or in oil and gas when it's about inspection of pipes, for instance. So many commonalities between the domains, and which helps also the SMEs that we were supporting to develop their market. So the SMEs, how did we reach them? We organized 2 open calls to distribute these 8 million euros with grants coming from starting from 100 kilo euros to 300 kilo euros, and experimentation that were lasting from 12 months to 6 months, 12 months, or 18 months. We selected these experimentations that applied to the calls with external experts to avoid introducing bias in our evaluation. And we, all along the runtime of the experimentations, we were more like mentoring these experimentation to help them develop their solution and bringing them our expertise of research and technology organizations of university to really develop their product and develop their services. So it was really to help them being successful. So I'll give you a set of examples of the experimentation. We funded 50 experimentations. So those that are selected are more or less related to transports and to road transport, but you'll see it's quite broad. So one of them is, the first one is about detection of cracks and repairing cracks. So it's complementary to the previous presentation. So it's after when you cannot predict. So it's an experimentation. I don't know if you'll see. Well, there is a video, but I'm apparently the only one to see it. I don't know if I can. No, I cannot. Yeah. Okay. Okay, I'll speed up a little bit. So this was a new machine completely developed with the funding that we provided. It's basically some kind of caterpillar on top of which the SME has installed a robotic arm off the shelf, equipped with a sensor to detect cracks in the pavement and fix these cracks with and fill up this. This was a project supported by Eurovia. This was one of the conditions to select our experimentation, is that these applications were supported by some end users and can demonstrate that they had some market. So we didn't want to have to fund. So that's a product now that is available, and generally we were willing to reach maturity level of TRL 6, 7, reaching having some proof of concept and or prototype at the but there is still then some effort to do afterwards for the SMEs to make a real product, but this is what we were really focusing on innovation. Another example is this robot for pipe inspection, which more closer to transport and road transport is this combination of a flying drone, and a quadricopter and a car to do some mapping of routes. And that was an application that was demonstrated in Spain and in the southwest of France. All these pictures are also to show you the vast variety of technologies that we are covering. You see, we have robotic arms, mobile robot, terrestrial robots, flying drones, and UAVs, water-going robots going under the water, on the water. So snake robots. So it's a very vast variety of robots, always designed to solve a specific solution. And this makes the specificity of inspection and maintenance of infrastructure with respect to robotics is that we cannot have one solution for which will be applicable for every issue. Again, inspection of pavement in airports with a drone. Some other examples here. Again another robot for detection and repairing of cracks on the roads. A magnetic robot that is also able to detect the cracks on metallic surfaces, and that was crawling along the surfaces, and also a specific robot that was using the infrastructure and the cables on the rails to control the defaults on the rails. Here at the center, one robot which was funded, one application will be supported with, I guess, a spin-off from DTI, again, gumbots that was designed to clean the pavement from gums. So if you want to know more, there are a lot of videos on that project. Inspection and maintenance of tunnels also, the road or railway tunnels, and it's to avoid accidents and procure some safety for operators in this inspection of tunnels, and also reducing the cost and time of this inspection. We also have these flying drones with fixed wings to do some inspection for roads. So this is to show you this vast variety of technologies and robots and services that we offered also to the SMEs. In total, there were at least we are trying to measure the impact of our activities in RIMA. At the moment, we know that there is at least 16 new services that were created and that are operational out of this 50 experimentation, and 25 new products. And that also the SMEs that we supported were able to raise funds, which is which represents at least the same amount of money that we gave them for their support. So direct contracts, and we think that this demonstrates the success of the network. And so now, what's next? RIMA will be finishing in June 2021. And we are creating an alliance, thanks to some ideas coming from FEHRL also. This alliance will extend, or will extend, yes, this idea of this network of digital innovation hubs, and the format that we have used. So the objective will be almost the same than the one we had in RIMA, much more focused on research, on understanding the state of the art. And yeah, sorry, I was late in my slides. So domains covered will be the same. Robotics also will cover this large variety of technologies. And we'll also enlarge our scope to different technologies than robotics itself, including AI and non-destructive testing, which is fundamental also in inspection and maintenance. So what are the benefits? It's maybe very small, but it's you see to maintain this coherence between the research organizations and universities that are interested in inspection and maintenance. We realize that whether we are working on drones or arms or snake robots, we are speaking almost the same language when we are dealing with inspection maintenance robotics. It's unique, non-replicable cases. We have to address the human-machine interfacing, the versatility, the reconfiguration, also the constraints related to costs, to regulation. So we have, and we'd like to maintain that with the alliance, and keep also this aspect and this idea of gathering or sharing information on what's happening in robotics. What is the state of the art? What are the progresses and so on? We would like also to be part of this action to drive the research and innovation and or drive the orientation of research and innovation with the EC, and especially we're working with the DG Connect and robotics and AI unit. The profile of the member of the alliance, you see, it's basically the same than what we had in RIMA. We work essentially with a sectorial association because it's easier for us to talk with one organization which can represent a community of organizations like FEHRL, like UITP yesterday, or these. We are, as in our members, we have also Water Europe, which is covering all the water sector, Nuclear Europe. So it's easier for us and to understand what are the real needs or the needs of a group of organizations. So we would favor sectoral association, but it's rather open. We have very little constraints in this alliance with the obligation to participate to 2 General Assembly during a year, so it's mainly about putting resources rather than there will be no fees, no transfer of money to participate to this alliance. If you want to have some detail, I will just switch over rapidly on that slide, because it's about the constitution and the role of the different bodies inside the alliance. If you are interested to take part of the alliance anyway, and again for the finances, it's simple as we can. No transfer of funding, no bank account. It's really something that we want to create this, to maintain this community, and to also support other initiatives like the association e-robotics, which is in this same building and also part of this board of director, ADRA, which is dealing with AI data robotics, BDVA, Sprint, the EC, and so on. So if you are interested in joining the alliance, you can contact me. There is a very simple process also with an approval by the General Assembly and the members. And that's all for me. Just if you want also to have more information about RIMA and the context, the network, and the products that are available, the Digital Innovation Hubs, the services offered by the Digital Innovation Hub, you can have a look at this community portal that will be soon transferred to the E-Robotics Association to maintain this robotics aspect also, which is important for us. So that was my last time. Thank you very much.
Thank you. Thank you. Okay, thank you, Christophe. Yeah, okay. It takes some time. Thank you, Christophe. So indeed, I think that we have a good taste of what all the experience you gathered within this project. So I already had a look to the website a few months ago, but I will go back and see definitely. Thank you. Yeah.
Thank you so much. Christophe, I was just wondering, could you elaborate a little bit more on the ongoing initiative? What does it require of the participants? Is there, X amount of meetings annually, or how do you organize that? Yeah. Sorry, I'm Maria from DTI, and I have colleagues that have been involved with the project.
Yes. So actually, the involvement in the alliance is very, very light. There is the only thing that we are planning is to have 2 general assembly in a year. So the first one will be held in Naples on the 19th of June this year. That will gather all the partners. Basically, all the partners of RIMA are now joining the alliance. So we've got the signature also from DTI recently. FEHRL also, so very, very light anyway, and the General Assembly, it's the opportunity to discuss about state of the art, relations with the different associations, organizations in Europe, to understand if they can express some needs regarding robotics, AI, and these technologies. Eventually participate to the preparation of road mapping and strategic research agenda, this kind of thing. So it's rather more research oriented, because we don't want to overlap with the role of the sectorial association, but we also would like to maintain this connection to have this industry-driven aspect in our thinking. So
Thank you, Maria, for the joke. I don't know if we have questions from the audience in the online. No, okay. So thank you, Christophe. Thank you for this complementary information. I think that we will need to indeed have a discussion also internally at FEHRL. We are setting new working groups, and they will be interested. Some will be interested, I think. So let's move to our next speaker. Thierry will tell us now a few words about. I will let you play with the computer. A few words about another project that is dealing with robotics. It's the project FEHRL, in which FEHRL has been a partner. So an Horizon project also coordinated by the University of Vigo. And it's about promoting significant advances in automating, robotizing, and modularization in the road construction sector. So I think that you also had 5 technological areas, and I'm very curious to see concrete applications in these technological areas.
Yeah.
Thank
Okay,
you.
so I need to reboot because it didn't work. But I'll do it. Yes, because we're also online, that's why, yes. So this session, the beginning is indeed focused on big data with BDPAVE. Then we dig into the broad perspective of robotization. And now we also have another, let's say, project on autonomous robots for inspection and maintenance. So this is a project where we have 42 months projects, about 5 million euro, let's say, budget, and quite a large, significant number of effort to go through these activities. It started about a bit more than a year ago, and so the project really has a focus a number of technological areas. So it cannot cover everything, but it does cover more or less throughout each of the steps in a way within the inspection and maintenance. So the first, let's say, technological area where we want to focus, or where we focus in this project, is about autonomous robotized machinery for construction, upgrade, and large maintenance intervention. So that's one of the aspects of the project. The second technological area is about autonomous robotized machinery for the routine or periodic maintenance of the pavement. So that's, one is construction, the second one is about the maintenance. The third one is introducing the modularization aspect, so modularization of road construction upgrade through industrial prefabrication. Then the fourth areas is about collaborative operation of safety cones, robots, and airpass for work zone segmentation and signaling. And the fifth area is about integrating all these, let's say, information into an upgrading of the management systems to ensure safer operations and maintenance for the workers, but also, of course, for the road users as well. So in this project, we really aim that all this this set of technology combined together, once deployed in a large scale, should really support, let's say, very large improvement of the road capacity. We expect to increase by 20% the road capacity, so that's quite substantial. In terms of safety, we also expect that these applications all combined should decrease by half the fatal accidents for the workers, but also in general of the road network. We also expect 20% of traffic, then I need to read because it's too traffic disruption, yes, thanks to the robots in a way being certainly working in different way and probably faster than the human being can do. And also a decrease of 20% of the routine maintenance cost. And well, this is also a very substantial element that drives in a way the work we are trying to do. So within this project and within each of these technological areas, so we are developing a number of solutions. I'm not going to go in detail for all of them, but I'm going to mention each of them. So in the first one is about the autonomous, let's say, tool that we are developing. It's actually autonomous and autonomized working road construction train, and this train include a feeder and a roller. And as you can see on the picture, this is a tool that we are currently developing. We are about 30% of development at the moment. And this tool will also include, at the bottom, you can see a specific device for the automated laydown of fiber optic cables during the paving process. So this is something that we also want to integrate directly into the pavement. And this is something we are about 10% of development. So it's a new project, as I said. It's about a year, so things are under development. There is also another application that we are developing for potholes. So we are developing a prototype to fill the potholes. And at this level, we are about 40% completion. So something that I also need to mention is all our applications are for asphalt pavement. So we are not dealing with concrete pavement. They are all for asphalt pavement. We also develop, we are currently developing an autonomously working line marking robot using cold paint. That can be something used not only for roads but also for parking slots. And at this level, it's about 10% of completion at the moment. So we are also developing in the modularized aspect, we are developing multifunctional precast concrete elements to be used on the roadside. And this one can embed a number of, let's say, spaces for wires for drainage, and a number of signalization aspects as well that are embedded into the system. We are also having other product under development. The other one is this time on collaborative operation between safety cones, robots, and the and let's say the system. So that's something that we are working at the moment. It's about 20% completion. The other aspect is about pavement management system. So we are currently developing an upgrade of the pavement management system, taking into account the introduction of the robotics. So that's a very important aspect because at the moment that's not done at all. So that is a new integration that we are doing. And we are also moving on product or services, I would say, with digital twins, which are based on application for the pavement management system. And last but not least, we are also developing, say, upgrade for the traffic management system, also again taking into account the introduction of the robotics. And that's something new that we are going to develop. We are about, again, 20% of development. So in terms of results, it's hard to say, that we are still far away from the end of the project, but we already have some results and some that are going to come. So we already have a patent developed for autonomous paver sensors control system. When I say it's almost finished, it's really in the last stage. We're also aiming at IPR protection for asphalt mixture to repair the small potholes and cracks by the additive producer. We also have in the product and service combined together, so autonomous line marking robot and support, the RPAS system for monitoring work zones, upgrade of existing PMS solutions, fiber optic solution for pavement damage detection. In a purely product-oriented results, we have this multifunctional precast concrete system and the digital twin-based add-on application that will also be there. So in all what I mentioned earlier, there are quite a large number of products or services that will be available at the end of the project. All of them should be reaching TRL 7. So that's a very large ambition. So this means that almost close to be at the introduction of the market. So in a nutshell, the focus of the work starts on the autonomous robotized intervention and modular solution. This is the core of the project. But then we also want, and we have some area of the work on autonomous robotized solution for work zone segmentation and signaling, and this is also done also with the drone as well. And then what we also want is to have all that integrated into the management system and of course the traffic management system as well. So this will be offering a complete, I would say, set of solutions. And with that, this should respond in a way to the directives and decision made by the European level from the smart green and integrated transport, but also the Vision Zero and the Digital Europe, let's say, framework. And as I said earlier, if everything goes well on the rollout, then this should have a really significant positive impact from the, let's say, the overall network capacity and the safety and of course the cost of the maintenance as well. So we are at the beginning of the project, but we already liaise quite a lot within the first year to promote these activities and also to create the awareness so that the upcoming products will be better known and uptaken. And today at FEHRL it was a good occasion to do this promotion. So with this, I will just end the presentation. Thank you.
Thank you, Thierry. I was just wondering, and I had the same question for Christophe, basically. When we see this application of pothole detection through automated system and repair, do you think that we will, in what time scale, could we find such solution on all roads? Is there really a real business model behind that can be viable?
So at the moment we are more on so we are developing the tool. So this tool will be, where we are very confident that the tool will be operational by the end of the project. That's one first element. Then we also have in the room and certainly within the project, we also have some potential buyers like industry on one hand, SMEs who are producing them, or let's say ready to produce them, and certainly the road authorities or the one that can use it, can use them. So there is no proper business model at the moment developed, but I mean I have no doubt that this is going to work. And for the people who are a bit familiar with Brussels and Belgium in general, I think they will be very useful. So
we have a good experience with potholes.
Exactly.
A longer one, yeah.
Yes.
We can export it if you want. Okay, thank you, Thierry. Any question from the room? Status.
Thanks, Thierry, for the interesting presentation. And I saw that main drivers or main imperatives were to reduce fatal accidents, to reduce traffic disruptions, and also to there was a further one. Reduce maintenance costs. So I was wondering if decarbonization and sustainability aspects were also addressed in the project, because from my opinion that deployment of these robot technologies that can contribute significantly to decarbonization as well.
Yeah, this is not really let's say the driver within this project, and I would say probably also within RIMA. This is very technology oriented. And it comes back to the session 1 of yesterday. I think in the whole field of work that we belong to, we are here to develop, let's say, practical solutions, mostly technological solutions. And somehow we may also need to do a step aside to realize, okay, do we have maybe the set of energy to feed all these machines? Because at the end, whatever they are, robots, they are AI, computers or whatever, they will need with energy. And this is going to be maybe the leading element. And that's also why yesterday we had this as a kind of introduction. It was very disturbing for us in a way, but I think this is going to be probably the leading one. And when we can see within the whole program and the Commission yesterday, I received, by the way, this morning a message from the Commission saying that they were very happy from this discussion of yesterday. Most of the programs are led by climate change, therefore CO2 emission, but they are not maybe enough led by the upcoming shortfall of energy, and mostly, you know, the primary one, oil and gas and coal maybe. And this one will eat us maybe faster than the climate change. So we may not reverse, but change a bit, you know, or accelerate some transition. But more than that, maybe think whether we need to not expand, but to multiply in an accelerated way the number of robots and so on. So we have to maybe, so we have of course to create the solution, but then in the deployment, maybe it has to be well thought how to deploy them in such a way that they are used in a good way and not like abusing in a way, if I may say it this way. So maybe you want to add something, because I'm talking now from the infrastructure, but the robotization world is maybe not happy with this.
Just concerning the first question that you had, yeah, there was when we selected the experimentation, we were really careful of having some expressions of needs from some end users, so that would be helping us, or the experts that were selecting the experimentations, to guess if there was a market. That was really crucial to have a guess about the impact, the economic impact, the creation, digital innovation networks have been, it's an idea coming from the Commission to, because of the complaints from the industry in the previous frame programs, FP 5, 6, 7, that the research carried out in these frame programs were not having any impact on the industry in Europe. So the digital innovation were some kind of instruments to favor this innovation, creation of value, and so we were very attentive of this market that to select the experimentation that we would be funding. But anyway, there is a set of steps to before people could go to the market. So in RIMA, we were more on proof of concepts, whereas I say it was limiting our activities to innovation, so TRL 6, 7 really maximum. But after that, the business model it's not so easy. The example of Eurovia with VLM robotics and all that. The technology is really, was really interesting because they managed to gather all these non-destructive testing, sensors to detect the cracks and guess the shape and fill up the, but at the end there was some changes in Eurovia, which and despite their engagement at the beginning to buy these machines, it couldn't be achieved as planned initially. This is for me anyway. Our role was there to demonstrate that the technology was available, and it's now a matter of the end users to trigger this development. And yeah, what we can say, we were not really looking, as you were looking in your project, for autonomy, but more for also capacities. What was more important for this, to answer your question concerning CO2 emissions and Green Deal and these aspects, that was not the criterion that we used to select the experimentations, like biodiversity also. It was not really our criterion. It was more about this impact on the economy in Europe.
Okay, thank you, Thierry and Christophe. Yeah.
Thank you for the presentation. I have a question, is especially regarding road markings maintenance. At the moment, the criteria to redraw or to repaint the road is based on some characteristics which are not digitalized. It's a laser scanner, some retroreflectometer, and in this robotics project, they use image processing. They use other technologies that cannot measure this traditional way of maintenance. So who will win, in fact? Do we have to change the way maintenance is performed, so the standards for maintenance, or digitalization will drive, in fact, a change in the way operations or infrastructure or designed? That's a question I have in mind every time.
We have a new project here. We have a.
Sorry? Well, I think
that's a new project.
Yes, exactly.
Nicolas,
I think it was not really a question. That is more like a comment, I guess. And I think to tell you who will win, we cannot say. But what is more likely to happen is that we move towards a digitalized world anyway. So this is going to change, and it will have certainly an impact on the standard at the point. When, it's hard to say, but I think it's more this, we are working on that way forward. So I don't think we will come back. So at one point there will be it's not a win, but just a change in a way. Yeah, that's what I would say, yeah.
Yeah, that's an important point, definitely. Okay, I suggest that we move. Thank you for questions and answers. I suggest that we move to our last talk for this first part of the morning. So it will be about the project Alarte. So I will invite, I will invite Maria Zabilde. So it's a project that is led by Tecnalia, Research and Innovation. And so we are moving from, I would say, from road to roadsides, as far as I understood the project. So it's about the monitoring of slope movements by cost-effective and reliable technology. So you will tell us a few words, several words about an automatic inclinometer probe that has been developed within the project.
Thank you. I will introduce the Alarte project. Alarte is an H2 2020 project, but it's a bit different from the previous projects presented because it's not a research innovation action or an innovation action. It's a fast-track project, and it aims at taking an existing prototype of robotic inclinometer to take it to the market. We should end up the project in FEHRL 9. At least. The consortium is composed by FEHRL, which is in charge of the dissemination and more things. Microsay, which is a Turkish SME, and they are in charge of manufacturing the prototype and scaling it up and industrializing it. FEHRL, which is a big, actually Dutch construction company, which are responsible of validating the prototype on site, and Sixth Sense, which is the French experts in commercialization monitoring equipment, and they are in charge of the commercialization of the product. And Tecnalia, we are coordinating the project, and we developed the first prototype. It started in 2020, and it's supposed to end by the end of this year. Well, as you know, landslides are a rather harmful threat, actually. Yeah, okay. A rather harmful threat, and which is increasing nowadays in the context of climate change and also due to the changes in land uses. These changes increase the rainfall rate, and this also increases, and the frequency and intensity of the storms, and this increases the groundwater pressure and also increases the weathering of the soil and the bedrock, which in turn increases the number of landslides. This fact causes damages of 18 billion euros per year at a global scale. And as I said, this number is increasing due to this climate change context and human activities. Therefore, monitoring slope movements is becoming a crucial task in today's societies. Currently, these landslides are monitored with manual inclinometers, are the most extended tool to monitor these landslides, which involves the deployment of equipment and operators on site. And this prevents from taking measurements at short periods with the frequency, with the optimum frequency we would like to. I suppose automatic inclinometers are capable of transmitting data in real time and However, the drawbacks are that they are very costly, actually, and they also usually require complex installations. The prototype we've developed and we are actually validating is an automatic inclinometer that can transmit data in real time, which is, as opposed to its competitors, it's really cost effective and it's very easy to install. So which are the actual challenges that we are facing? There's a need to improve operational and risk management capabilities. We need real-time and accurate deep ground monitoring. We also require data-driven decision-making processes, issuing automatic alerts. And there's a demand of a competitive, easy, and cost-effective tool for an efficient decision-making. So this is I'm afraid I will not be able, oh yes. Okay, this is the solution that Alarte proposes. Alarte is a remote and competitive robotized vertical inclinometer with a controller, which ensures continuous online risk awareness and timely response. We can take as many measurements as we like. Just once we have the equipment installed from our office, we can ask through through an application installed in our mobile phones, for example. We can require as many measurements as we like. I'll show you a example. This is a video from Sixth Sense, which is in charge of the commercialization. It shows how the system works. It's like a box. Everything is all the equipment is allocated within this box, which attaches to the top of the borehole of the inclinometer case. Okay, I cannot see well. Those are the elements, the battery and so on. Here it's you fix it to the top of the inclinometer casing. It goes down. Well, it goes wherever you want. You can order it to move and stop at the intervals you at the length you want. For example, it's 0.5 meters down to whatever and up, and go up and down as many times as you like. You see it's moving. And it sends the signal to your receiver in your office, at your office. Okay. Those are the applications. You can apply it for monitoring landslides or monitoring the stability of mines, for underground excavations, to monitor the stability of the retaining walls, for example, for urban excavations, and for dams as well. So which are the benefits? Alarte provides accurate and reliable data. It issues automatic alerts. You can set alerts when you exceed a certain amount of movement. It's easy and quick to set it up. It's a flexible and autonomous system. It improves risk management, and most important, it has an attractive price. As I mentioned, in the video, it can be applied to monitoring landslides, mines, the stability of hydraulic infrastructures and transportation infrastructure. Now we are currently validating the prototype. It's been installed at the construction site in Murcia. It's FEHRL's site. They are building Murcia's arterial railway. I think it's a high-speed railway. We've installed in Alarte inclinometers in 5 zones with different movement expected. We've installed at each section a couple of inclinometers on both retaining walls. It's a cut and cover excavation, and we have installed them there. And we've also installed conventional inclinometers to check whether they perform the same or. And up to now, we've found out that, well, after making some adjustments, and we found out that it's very reliable and accurate as compared to a conventional inclinometer. And well, the problem here, one of the main problems here, as it's an urban environment, because it's a station, a railway station, we have vandalism problems, which we are trying to solve, because it's fed by a solar battery. So we've redesigned the system for to making it more difficult to take it. We are also improving the resistance against corrosion for a long time. We are also trying to develop as robust a system as we can, because it's supposed to be installed for long periods. And we've also changed the battery to extend its duration. Well, and there are different options for the different. So this is the output you would get from your office if you call the inclinometer and you make it move, and then you get the result of the movement. Okay, so I think that's the end of my presentation.
Thank you, Maria. Very interesting to hear about a project that would deliver, a product so close to the market. That's one of the first time I see. I heard something about a fast-track innovation project. So for me, it's very interesting. So, do we have any question in the room or maybe online? So I do not. I still hope we could have no reaction. Okay. So it's time for the break, definitely. So you are maybe yes, would like to have a coffee. So we'll reconvene at 10:45, so 10:45, and Yanis Barbas will take over the moderation. So Yanis is FEHRL board member, a long history in FEHRL, so you will be in good hands with him. So please enjoy the break. So as I said, we come back at 10:45. Thank you for your attention and questions.
Okay, good morning everyone, and welcome to the last session. We have still 2 projects to be presented today before closing our FEHRL 2023. And the first one, it's my pleasure to welcome Adevoli to stage to present Myriad project. Probably I will not go into detail because it will be revealed by you.
Yes, yes.
Thank you.
Thank you, Yanis. Good morning to everyone. So I'll be presenting the Myriad EU project. Myriad EU stands for Multi-Hazard and Systemic Framework for Enhancing Risk-Informed Management and Decision-Making in the EU. So the project consortium consists of 19 partners, and it's led by VUB in Amsterdam. The project started in 2021, and it's an Horizon 2020 project, and the planned end date is 31st of August 2025, with a budget of around 5 million euros. What we plan to do in the project is, I think, better explained in the short video that you'll watch in a moment. So in December 2021, an eruption occurred in Tonga called Tonga eruption, leading to, of course, large direct impact on the surrounding areas. It's reported that at least 4 fatalities, many were displaced and injured. Asphalt covering and destroying buildings and infrastructure, lack of clean water, impact on agricultural production, etc., etc. And this eruption led to many other impacts. For example, it led to a tsunami very close to Tonga itself, but it also caused damage in the harbor of Santa Cruz in California, right across the Pacific. But also impacts of the tsunami were also felt along coastlines in Peru and Japan. And due to the fact that Tonga was hit by both a volcanic eruption and the tsunami, they were in need of humanitarian delivery and in humanitarian aid in terms of food and water. Well, unfortunately, the aid delivery also delivered the coronavirus to the island for the first time, making it even more difficult for the island to recover. So this example showcases that the interaction between various hazards can lead to a greater impact than the sum of a single event. Well, secondly, the closer to Europe, in February 2022, we had this storm triplet called Dudley, Eunice, and Franklin, which occurred in February last year. This was quite unusual because it brought 3 storms in the same region in Europe, one after the other, within the span of 1 week. And most especially the storm Eunice, which was at that time recorded as one of the strongest storms on record, with a peak of around 200 kilometers per hour. So the impacts, the storm Eunice caused about around 20 known fatalities with multiple injuries. Of course, together with the economic damage of the 3 events, which was quite huge. Millions were left without power, and huge and, of course, prolonged disruption to travel and business. So this shows that consecutive impacts can build up compared to a single event. So within this project, we are addressing several issues. Firstly, that multiple hazards can have interrelated effects on risk. And there are many ways in which this can occur. You can see the 4 different examples I'm about to talk about. So for example, the triggering. So one hazard can trigger a different hazard, such as intense rainfall can trigger landslides. Regarding the amplifying, the combination of different hazards can amplify the likelihood of other hazards occurring. So for example, during hot and dry conditions, the chances of wildfires can be amplified. Then the compound effect, the compound event can occur. One more than one hazard can occur at the same time. For example, like when river and coastal flooding occur together in a delta. And this can, of course, lead to very large flood disasters. And then the consecutive, and as shown earlier, consecutive hazards can also increase the risk. So the question we're asking here is how can risk, the key question is how can risk be better managed by considering these interrelated effects? Secondly, we also know that disaster risk measures taken to reduce risk from one hazard can sometimes actually increase risk from another. The example you see on the screen is a house that was built in a flood-prone area that was built on stilts. So while this makes it, of course, it makes the house less vulnerable to flooding, as the photo shows, it actually made it more vulnerable to shaking during earthquakes. So the question being addressed in this project is how can we better account for these dynamic feedbacks between risk and drivers. And then thirdly, interrelated effects have impacts across sectors. Hazards and their interrelation can also have, it can affect different sectors at the same time. The picture you see on the screen is from a beach in Los Angeles. This area is on the coast, and so it faces coastal hazards, but Los Angeles, as we know, is also prone to earthquakes. So in this picture, we see actually different sectors sharing the same space. So you see tourists on the beach, you see a power station producing energy in the background, etc. So the question being addressed in the project here is how can we account for these trade-offs and synergies across sectors, across regions, and hazards. So the vision and aim of the project is, the vision of the project is to catalyze the paradigm shift required to move towards a multi-risk, multi-sector systemic approach to risk assessment and management. So in other words, not to take risk, single risk, or not to look at hazards as single hazards, but look at the combined effects of all these issues. So the overall aim is that myriad EU policymakers, decision makers, and practitioners will be able to develop forward-looking disaster risk management pathways. And I think this is the main goal and aim of the project, forward-looking disaster risk management pathways that can assess trade-offs and synergies across sectors, hazards, and scales. So the project is focusing on 5 multi-scale pilot regions. where we aim to better understand indirect, interregional, and cross-sectoral risk within Europe. So you can see on the screen the 5 multi-scale pilots. So what is being done in the project is that in each pilot, we first define a sustainable challenge. So for example, for the Danube, sorry, I can't see it, for the Danube region, you can see that we have quite a number of sectors, and how can we take into consideration resilience, so then what we do is that we then involve stakeholders from different sectors to discuss ways to achieve that challenge. And of course, in so doing, we address all the different possible hazards and the combination of hazards. So as you can see, for each pilot, there are different possible hazards that can take place, and different affecting different stakeholders, and how can we together involving stakeholders to discuss ways to achieve this challenge. So the consortium itself is quite a broad one. As I said, it's led by VUB. We have partners from all across Europe. And so one thing it's been done in the project is to take on board sectoral representatives. So we have 6 sectoral representatives, organizations covering sectors like the energy sector, tourism, finance, food and agriculture, ecosystems and forestry, and of course infrastructure. And this is why FEHRL has also been invited to take part. So FEHRL itself, we are not involved in the research per se, but just giving advice on the infrastructure part and how these hazards can affect them. So I'm not going to go through this, but the project itself is divided into 5 steps. The first step is about the diagnosis, where we bring together all the stakeholders to get an understanding about each other's perspectives. So the way of working, the challenges, understanding past methods, understanding models, tools, policies, governance of multi-risk management, etc., etc. So this of course has been achieved, and then the second step is the development of an initial framework for multi-hazard, multi-sector risk management. Yes, so so I'll just go through some of the results that have been achieved. So far, the project, as I said, started in 2021. A handbook of multi-hazard, multi-risk concepts, definitions, and indicators. 2 reports actually, and the handbook and then the report on policies. There is an online wiki platform that has been developed. Pilot workshops have been completed, etc. So I will just briefly show you so these 2 key handbooks and reports have been developed, which bring together, the first one, the handbook of multi-hazard, multi-risk definitions and concepts. It brings together important terminology and definitions that are used in the multi-risk literature, as well as giving an overview of key indicators and approaches that have been identified in the literature. In addition to that, we've also developed a report on policies, policy making, processes, and governance for multi-hazard, multi-risk management. So this the input from these 2 reports, the findings, I should say, of these 2 reports have been used to populate this wiki platform. It's called Disaster Risk Gateway, and it's a toolbox for disaster risk. And And three main purposes for developing this, this wiki. The first of all is to serve as an information resource and starting point to encourage engagement between different actors, to promote interdisciplinary research, and of course to act as, for research activities within the project itself and other, and support for other future projects. So this platform will support the wider hazard and risk management community to help them to increase their understanding of what is possible and how the knowledge can be applied to different disaster risks. So for example, including multi-hazard, multi-risk challenges. So so it's just a screenshot from this disaster risk gateway. Of course, it's accessible online, and it contains key information, as I said, from these two previous reports. That's the multi-hazard, multi-risk policy and governance review. And the plan is that the gateway will continue to develop dynamically and over time as new information and new materials are developed within the project. Well, secondly, part of what has been the result is an initial version of the framework for multi-hazard, multi-sector systemic risk management has been developed, and this was mainly based on desk research and consultation with stakeholders at different workshops that have been prepared within the project. So what we've done is that this initial version of the framework was presented to the pilot workshops. We talked about 5 pilots that have been addressed within the project. So they've been presented to the pilot workshops last year, and the general feedback is that on the usefulness has been quite positive. So the testing, of course, feedback and improvement of the framework will continue throughout the project. Just an overview of the pilot workshops once again that has taken place in the project. Some of them were online, some of them were on ground, and further workshops will take place, of course, as we develop this framework and implement them on these workshops. So that's just a general overview of the project. Our role as FEHRL, as I said, is to engage our experts from within FEHRL institutes to take part in these workshops, to provide input, and thanks to the colleagues from BAST, for example, they've been active in one of the workshops for Danube, and from Katia in Hungary as well. So this is just an opportunity to also inform you that if you have experts that are involved in multi-risk, multi-hazard concepts, please let us know. At the office, of course, we are not experts on this, but we're just facilitating the engagement of FEHRL experts to get used to it. And so, yeah, if you want to stay informed about the project, you can see the website. The website is on the screen. You can always register for updates or send information to your colleagues to do that. We are also active on Twitter, and you can follow us on this project. So this project was also presented 2 years ago at the 2021 FEHRL event, and from that we were able to engage with BAS. So once again, please, any interested organization, FEHRL institutes, please let us know, and we'll be happy to link you up, your experts up with the research part of the project. And that's all from my side. Thank you very much.
Polly, is there any question in the audience? Are there any questions, hopefully? Oh.
And thanks, Wally. I was just interested in the disciplines in the project.
Yeah.
I imagine it could be very diverse, or do you have, or maybe can you just describe I suppose, the different skill sets within the consortium that are looking at this?
Yeah, as I said earlier, there are 6 sectors. I think that's what you had in mind, right? 6 sectors that are involved. So we have organizations dealing with energy, the energy sector, tourism, for example, finance, food and agriculture, and infrastructure, and the last one, forestry, ecosystem and forestry. So the idea is that when hazards take place, not only one sector is affected, so the different sectors are affected. So the idea is to bring together all these experts to see the impact of this multi-hazard, multi-risk on the sectors. So it's been quite interesting because you find out that it's not when flooding takes place, for example, it's not maybe only the infrastructure that is affected, or maybe agriculture is also affected. So it's really a very interesting project, and as I said, I mean, we are very much open to involve FEHRL experts to get in touch with the project. Yes.
And maybe if I also give additional, so more than the domain, so I think you also refer to the, let's say, the disciplines in a way. So in this project, there are more or less all disciplines from hard civil engineers to social specialists and so on, because this is to cover the whole chain of impact, including, of course, at the end, the very end user. For instance, we have also cities involved, regional planners, because they have to implement this in their strategy. So yes, so it really covers the whole range of disciplines, which makes it very complicated, even to talk and to understand each other. Yeah.
Thank you, Thierry. Thank you, Wally.
Thank you.
Looks like we are transforming or transferring from risk management to nuisances and low noise. Judita, the floor is yours, please.
So good morning, everyone. If we can still say it's morning. First of all, I would like to thank you all for being here, keeping in mind that it's the last presentation. So I'm happy to see all you here and for your interest in low noise pavements, which I'll present today. For those of you who don't know me, I am Judita Škulteckė from Road Research Institute of Vilnius Gediminas Technical University and a leader of this initiative. Today's topic is of particular interest since road traffic noise is the second biggest environmental problem in Europe, which negatively affects health after air pollution. It is estimated that at least 20% of EU population, it means that 1 in 5 people are exposed in traffic noise levels higher than 25 decibels during day, evening, and night period. This threshold is defined in the Environmental Noise Directive, and according to this directive, actions have to be taken to reduce this noise in the areas where these high levels are. The conducted studies show that exposure to high levels of noise cause annoyance, and more than 22 million Europeans feels this. And it also disturbs sleep. About 60.5 million Europeans suffer from this. In addition to this, noise pollution leads to irregular heartbeat, and it causes heart diseases. Annually, 84,000 cases are diagnosed, and sometimes it even leads to premature deaths. Annually, it's about 12,000. Seeking to reduce these high numbers, it is vital to understand how noise is generated. In general, road traffic generates noise by engine and by interaction between tire and pavement. The engine noise is reduced over the years, and considering the wider uptake of electric vehicles, the tire pavement noise is becoming dominant even at low speeds. As a consequence, we should pay more attention specifically to tire pavement noise. The level of tire pavement noise depends on the driving speed, on tire characteristics, and on pavement characteristics. First two of them are selected by the drivers, while the last one is significantly influenced by the government policy. It means that we can significantly reduce the traffic noise by requiring specific pavements. In this case, it's low noise pavements. As you can see in this slide, the experience among countries differ in low noise pavements. The Netherlands is a pioneer in this field, and there were the first trials constructed even back in 1972, and as a result, today more than 90% of their network is covered with low noise pavements. Other countries, for example, France, Germany, the United Kingdom, also focused on this topic quite early. However, the highest interest in this field was observed in the last 10 to 20 years as a result of mandatory application of Environmental Noise Directive. During these years, many projects focused on low noise pavements have been successfully implemented. Some of them were focused on the development of pavements itself. Some of them analyzed how the trial sections perform. The other were focused on the methods and techniques for noise measuring. Here you can see some of them in which FEHRL and FEHRL members were involved. However, many questions are still unanswered. And for example, how to improve the resistance to raveling? What is the main cause of premature failure of low noise pavements? How these pavements perform in cold climate and how to improve this performance? What methods should be used to measure noise, since as we know there are several of them and different countries use different methods? How to maintain and how to extend the service life of existing low noise pavements? Seeking to find answers to all these questions, FEHRL members launched an initiative, Low Noise Pavements. We are happy to see that 12 institutions expressed their interest in this and have already joined it. The overall aim of this initiative is to collect existing experience and to share best practice within FEHRL members and of course with the members of initiative itself. For this purpose, the survey was conducted among FEHRL members last year. I would like to thank you all who contributed to the collection of the data, because it was really a challenge and we asked to provide a lot of data, and we know that not all data are available and there are some contracts and so on. So thank you everyone for helping us to collect all this data. And the survey was dedicated and covered several different aspects. We asked to provide what types of asphalt mixtures are currently used to reduce tire pavement noise. In which areas these asphalt mixtures are used, what binder and what content is used, what characteristics of aggregates have to have, and what the exact values are. As well, we asked to provide what requirements are for the asphalt mixtures and what the actual characteristics exist, what requirements are for the constructed layer, how these constructed pavements perform, and how they are maintained. As you can see, the scope was really quite wide. So we are happy that 13 countries provided data. And now the data analysis, and now the group is focused on the data analysis. First results of this data will be presented in the Forum Acousticum, which is organized by the European Acoustics Association. So for those who would like to learn more about low noise pavements in Europe, where we started and where we are now, let's meet in Torino in Italy this September. Thank you.
Thank you, Dita. I'm sure there are questions. I'm sure. No? No. All right. It seems that, well, everyone will be in Acoustica.
Okay. It's nice to hear.
Yes.
And if everyone would like to join or will have any questions or any data which you would like to share, please let us know. Me personally or FEHRL office, we would be very happy.
Yes. Thank you. Thank you so much,
you.
Judita. I think I have to give floor to Thierry for closing words.
Yeah, thank you very much. So, Judita, you have great power of low noise. You see, there is no answer afterwards. So this is great. So thank you very much for well attending this last session. And well, it's time indeed to wrap up and to end our edition 2023 of FEHRL. So well, you've seen we drafted a program which was a bit different than before. We, of course, started from our route research on road transport and road infrastructure in particular, but we have largely expanded our, let's say, scope, especially in the debates. This started yesterday, and probably some of the conclusion we can get from what we heard in the first session is we certainly need to continue developing good research and innovation, but certainly also to consider more some drivers. And one of the key drivers that probably we could understand from yesterday is not only the CO2 reduction, but is a shortfall of energy availability, and in particular, I would say the fossil fuels and coal in general. So some of the of perspective needs to be a bit changed. Then also you understand that beyond the climate, which tends to hide the forest of biodiversity, in a way the biodiversity may hit back on all of us, not only for transport, but simply for our way of life. And this is what we wanted to address yesterday. Infrastructure is indeed an important impactor on biodiversity. You may just remember the figure of yesterday. In Europe, in average, we have a medium distance of 1.6 kilometers between two transport infrastructure. And of course, you could see the Netherlands in the, of course, in let's say in a very upfront for the low noise, but they are also even more dense. So this is just an average in Europe, which makes you know, a large impact on our biodiversity. And if we also integrate the energy grid that will need to support the electrification of transport in general, and especially road transport, we could imagine further infrastructure network to be built in the future with more impact on biodiversity. So that's a lot of things that we wanted to highlight yesterday. Well, automation is something we can't, let's say, neglect. We are all interested in this development. This is also what we wanted to address yesterday with a strong focus on CCAM, so connected and augmented and automation in a way, automated driving. Probably you understand that the technological development is not yet there. So we hoped that a few years ago. We realized that it will go less fast than expected. And probably one of the other elements that we also realize now is that we should also maybe not think about the full deployment of automated toys everywhere, but maybe a focus on some areas where it is more important. And well, again, link to what we also said with BDPAVE and digitalization in general is if we develop sensors and let's say digitalization tools, let's try to make them also useful not only for the monitoring of our road, but for supporting deployment of CCAM, but also for supporting the biodiversity, sensing and mapping. So yeah, a lot of things needs to be more integrated, which makes it even more complicated. With also some comment about the disciplines. So we used to be within FEHRL maybe a group of hardcore engineers dealing with hardcore business. And now we have to open up to disciplines that we are not used to and familiar to work and even discuss with. So that's another challenge that is ahead of us. And I think in the presentations that you heard this morning, you can see that. You could see, this development, and you could also see that within the research, we also have been more used to work on, let's say, applied research with a level of between 3 and 5 from the TRL level perspective. And of course, we still cover them, but we have now more and more also activities throughout the pipelines. And you could see this morning some example from, let's say, more lower TRL, medium TRL up to the last level with TRL 9. So this is a whole chain that we also try to do, which also makes different way of working and also probably linking more the R&D with the business operations. So with that, I'd like first to thank all the speakers who contributed to the session. Maybe if they are not all here, I'd like first maybe to give a round of applause for them. I would like to thank the audience who did pay the travel here, and well, I hope that you have enjoyed this session of 23, and certainly for all the one online. We can't see you, but we thank you for your attendance. And I also would like to thank very much all my colleagues from the FEHRL Secretariat that have spent many hours. I've been stressed quite a lot in the last month just to get this edition 23 in place. So we'll not name them because you probably know them, and if not, you can get the detail on the website. So one big round of applause for them. And to conclude, there is food for not only for thought, but also for let's say, remaining ourselves, so just outside. So thank you, and looking forward to see all of you next time.